Hi guys, here's another video about the CSS Pure Mathematics Exam from 2023. Today we are going to start with section B, and this is question 4, item A. So it asks us to find the value of theta and the limit we have here in order that the limit is finite. So let's begin. So suppose the limit is finite and let's call it L. Then we have that the limit is by definition this expression. But now recall that the sine of 2x is the same as 2 cosine x times sine x. So we can rewrite the expression this way. Now observe that we have sine x here and here. We have sine x 2 times. So we can simplify this expression a bit more. And the limit can be rewritten this way. Now, let us recall a fundamental limit, which is this one. We know that the limit when x goes to 0 of sine x over x equals to 1. And therefore, since this limit is non-zero, the inverse of the limit of the inverse of this expression is the inverse of the limit, which is 1. So the limit when x goes to 0 of x over sine x equals 1 also. Now we are going to use this information. So since we have L equals this expression here, and this expression equals 1, we can write this. So L, which is the same as L times 1, is the same as the expression we obtained times this limit, which we know is 1. But now recall that when the limit of a product is the product of the limits as long as both limits exist. So since we know that both of these limits exist, we can rewrite the expression this way. So the product of these limits is the same as the limit of these products. Okay, now we can simplify a bit, because here we have sine x and here we have sine x, and as long as we are close to 0 but not in 0, we can cancel both sine x's, and the same for the x's, because we have x up here and here we have x cubed. So we can rewrite the expression this way. Now let's look of what we have until now. So first, the limit we have here in the numerator when x goes to 0 is 2 plus theta, because the function cosine is continuous at 0, so the limit when x goes to 0 of 2 cosine x plus theta is the same as 2 cosine of 0 plus theta, which is 2 plus theta. And the denominator, the limit as x goes to 0 of x squared is 0 squared, which is 0, because again, x squared is also continuous. And by assumption, L is a real number. So the only way we can have that the limit L is a real number is if 2 plus theta equals 0. Because otherwise, since the limit when x goes to 0 of x squared is 0, we would have that the limit would be infinity. The limit would be either minus infinity or plus infinity, depending on the sign of 2 plus theta. If it were negative, since x squared is always positive, except for 0, then the limit would be negative, and if it were positive, the limit would be positive. So we must have 2 plus theta equals 0, and therefore theta must be minus 2 in order for the limit to exist. So theta must be minus 2, and the limit and since we have manipulated the expression and saw that L equals this expression here, L must be the limit as x goes to 0 of 2 cosine x minus 2 over x squared. So now let's go to the second part of the problem. We already know the value of theta, which makes the limit finite, and now let's calculate the limit. So we have achieved this expression, the limit is this, now we are going to manipulate it. So we have a 2 here, So we can rewrite the expression this way. And now we are going to use a famous trick, which is multiply and divide for the same object, for the same expression. So this expression is the same as this one, as long as we are near 0, because cosine x plus 1 is continuous. So we have this limit equals this one. Now observe that cosine x minus 1 times cosine x plus 1, we can simplify this and write as cosine x squared minus 1 squared, which is 1. So we can rewrite the expression this way. And now we are almost there. Now let us recall that we know that sine squared x plus cosine x squared equals 1. So we can, from this we can see that cosine squared x minus 1 equals minus sine x squared. So we can rewrite this way. Now we are just going to rearrange this expression a bit. So we put the minus and the 2 in the other member of the product, and we wrote sine squared x over x squared as sine of x over x squared, as we have here. Now let's look at this expression. Again, we know that the limit when x goes to 0 of sine x over x is 1. So if we square this limit, it's the same that we take the limit and then square it. It's the same. And this expression here, when x goes to 0, cosine of x plus 1, cosine of x goes to 1, and therefore the expression we have here in the denominator goes to 2. So this limit also exists when x goes to 0. Independently, they exist. So again, the limit of the product is the product of the limits, and we can make the manipulations we are going to do next. So we can write first the limit of the product as the product of the limit, because both exist separately. And now we can exchange this limit we have here. We can put it inside the square. So as we do here. Again, because the limit exists, so the limit of the product is the product of the limits. Now, what we have here inside, we know it's 1. So this is the same as 1 squared. And what we have here inside is cosine 2 minus 2 over cosine of 0 plus 1. But cosine of 0 is 1, so here we have 2 over 1 plus 1, which is 2. So minus 2 over 2, it's minus 1, and here 1. So the limit is minus 1, and we are done. And that's it for this video. I hope you enjoyed the video. Please subscribe to the channel, leave me a comment. I would love to hear what you think about my videos. If you like it, please let me know, and also share with your friends, because I really need subscribers. Thank you very much. Bye.